pulses. Like many applications have code like this. Basically, these 3 slides I shamelessly copied from the Node.js introductionally slideshow, which was made on JSConf 2009, but they like in very plain way explain that. So, but many web applications have code like this. They just query database like synchronous way. What is the software doing while it queries the database? Many cases just waiting for response. How much waiting can cost? Yeah, as you see, for example, if we're talking to the disk, we can do many things in the same time. So better software can multitask. So code like this blocks entire process for the time while we wait for the result. But code like this allows the program to return to the event loop, so we can do other things and be more efficient with our code. Yeah, so this is how I/O should be done, and this is what was introduced with Node.js. And this is the reason why Node.js is quite revolutionary. So for more details on that reasoning, see the JSConf slides about Node.js. So how to write asynchronous code? So Node.js introduced the following convention. You see we have an asynchronous read file function, which takes a callback. And this callback handles both error and success. As a first argument, we receive eventual error, if there's any, and in the following arguments, we have the result of that function. So this style has also its recommendation in W3C now. And it's a very good way to, when you deal like few asynchronous tasks, just do this. It's perfect. So let's do a simple real-world exercise. Concatenate all JS files in given directory to lib.js file. Thinking synchronous, it may look like this. We run readdir to take like an array of file names from directory. Then we filter it to take all JavaScript files, but excluding lib.js. And we are reading content of each file. It's plain JavaScript, yeah? I hope everyone gets that. So we are mapping like read file for every file name, and it will return content of that file. This is how we imagine it thinking synchronous, how we'll do it. And then we join it, and afterwards we write it to the lib.js. Pretty simple. Let's do it asynchronous in Node.js. This will look like this. Yeah, it's a bit worse. I just try to explain. Any vodka? Okay. All right. Maybe this one will be better. So here we have we're handling error for any error if there will be on a readdir file. Here we need to do the same for the like read file, but also we take all files content instantly. We don't know for which file we take content, which would be the last file that we'll have content for. So that's why I need to like, build like waiting number, which we increment and decrement, and then we know that we have all files and we can write it. So it's a bit more complicated. Some people like it. And for this example, it might be even okay to use it, but real-world examples are much more complicated. So yeah, it was quite simple, but real work is usually much more complicated. But we can write asynchronous, pretty simple asynchronous. I will show you how to do it. So yeah, many developers reach that point, and as a result, we have many solutions. Basically, many people say that if you try to write asynchronous, it's good if you write your own solution just to get familiar with that asynchronous coding. So most popular current solutions are async. Async basically provides took out some common patterns from that asynchronous callback style and provided like about 20 functions that you can write them more easily. Step is like very simple version of async, has like 2 or 3, I think, function, which also helps you with dealing with that callback style. Queue is an implementation based on promises, and on promises I will concentrate in following presentation. Sec is like similar as async, but about different API. and futures. Its promises alike, but it's not as monadic, not as versatile as promises. So, but deferred is the implementation that I wrote in, and I will present the next slices and solution based on that. I think it's the most simple and most straightforward promise implementation now. It's quite new. Version 0.3 was released last week, so it's by no means popular yet. Yeah, most solutions just try to simplify callbacks. That's what I said, but it can be done better than that. And so instead of encapsulating waiting state, we can return such state as an object, and it's what promises are about. With the deferred promise approach, an asynchronous function returns a promise object, which is a promise of a value to be obtained. Promise can be processed by many functions, many objects. It can be changed to other promises, chained to other promises, or nested with further promise values. With promises, we receive much more powerful abstraction of asynchronous programming. So, deferred promise concept. What is deferred? Deferred holds both resolver and the promise objects. That's deferred. Observer interested in value are attached to promise objects. We are just attaching callbacks to promise object, and we resolve promise with a resolver. Yeah, in older implementation, basically promise and deferred, all of this was one object. Like we resolved promise with a function on a promise, and we had the callbacks with a function on a promise as well. But with Qt it has changed. Like resolver is a separate object and promise is separate. So we just return promise to the world, and we keep resolver internally. So let's say external code can't resolve our promise. So example. Yeah, delay function decorator. So it will produce same function, but with delayed execution time. As you can see, yeah, we take the function and the timeout in which it has to be executed. So the return function will first create deferred object. Yeah, and we will time out call of that function, and we will resolve promise with the result of that function. And we return promise. So simple example, delay that, yeah? Nothing useful, but it shows the concept. So we have a function that adds two values. And it will, with that, it will be invoked in 100 milliseconds. So we are expecting result. We are calling delay at with 2 and 3, and we receive a promise. Now we attach the observer, and after that 100 milliseconds, that observer is called with a value. What is a promise? Yeah, this is a nice explanation. Promises are polymorphic, equi-recursive, abstract structural type encoding a monadic style of asynchronous programming in JavaScript. Yeah, I hope you understand that. Don't worry, you don't need to understand that. It's easy and powerful. You don't need to know what that means. Yeah, so maybe you try plain English. Yeah, promise is an object that represents eventual value which may be already available. It may be already available, or is expected to be available in future. Promise may succeed or fail. Promise can be resolved only once, no exceptions. Attaching observers. So in most known promise implementation, you do it this way. There is a then method on promise, and you put on success and or on error callback. Yeah, both callbacks are optional. You can provide either on success or error. Callbacks are called only once, and only either on success or on error is called. In deferred implementation, promise equals promise then. So basically, promise is promise then function. So you can use it directly, like it's below. Promise on success on error. Chaining promises. Promises by nature can be chained. So promise function returns another promise, which is resolved with a value returned by a callback function. So here we have delay that. We attach our observer, which returns some value. So that attaching observer also returns a promise, which resolved with a value 5. Yeah, yeah, like it's here. So we can attach another callback, and we get that value. This is synchronous inside, but it can be also asynchronous. So it doesn't matter whether inside is asynchronous or synchronous code. If no callback for a given flow, success error is given, the promise is resolved with input value. Like here, we omit on success handler. So it just passed down to the next callback with the result 5. Instead of callbacks, you can also pass promise values to promise. And in fact, any value, but I didn't want to talk all the secrets here. So for example, promise 3 in the below example is resolved with the value of promise 2, but only when both promise 1 and promise 2 are resolved. Nesting promises. Promises can be nested. If a promise is resolved with another promise, it's not really resolved. Promise is resolved only when the final promise is resolved with the real value. And as in this example, you can see we create an unresolved promise with deferred, and we resolve it with promise returned by delay add function. So the final result of that previous promise is the result of that delayed add function, but resolved, not really promise. Error handling. Errors in promises are handled in separate flow. And this is what makes writing with promises very clean. So a promise with resolved with an error rejected propagates its error to all promises that depends on this promise. It means like we attach those callbacks, this creates promises. So those are the dependent promises. So for example, here we have a promise, we attach success function, but this function throws error. This will be the result of the promise, which is the result of attaching that callback. Yeah, so the next success function is never called. But however, if following promise, we are attaching on error handler, it will go to there. So when there's no error callback passed, eventual error is silent. It's not good. So to expose the error, remember, and if you don't handle error, remember to end promise with end, so that error will be thrown. Because otherwise, eventual error will be not exposed. So there will be something wrong with your application, and we won't know why. It's very important. Errors can also be handled via end call, so you can also handle that final error there. Working with Node.js callback style functions. Yeah, this is quite important because most Node.js, all Node.js asynchronous APIs made callback style. And we really would like, if you would like to write it with promises, how to do this. So it's not convenient to work with both styles. Don't do this. If you decide to build your flow with promises, don't mix concepts. There's a function which will produce promisified version of such asynchronous function. So there's a deferred promisify. So for example, here we promisify read file function. As you can see, it works as a promise. It's not convenient for one function. Don't do that for one function. But it's convenient when you work with many more calls. So what's also important, deferred promise also takes care about input arguments. So it makes sure that all arguments to be passed are resolved before it calls that asynchronous function. So we can write constructs like this. This is both asynchronous functions. So we can just, when we work with promisified versions, we can just do read file and input it directly into write file. It looks like synchronous code, but it's asynchronous. Yeah, but this is a bad example in the world of Node.js. I mean, it's not efficient to do it exactly that way. But I just presented the concept here. Grouping promises. Sometimes we're interested in the result of more than one promise object. We can help us again with the deferred function. Deferred is a like kind of bit magic function. When called with no arguments, it returns unresolved promise. And resolver, when called with one argument, it returns resolved promise, which values that argument. If we call with many arguments, it will return the promise, which is resolved with the RI. That is each argument but resolved. So if you pass promises, it won't resolve before any of this resolves. Like here on delay that example. So processing collections. Like there is a promise-aware arrays map. So as you imagine, it won't resolve an array after it has actual values. Like we have asynchronous read file, and it will the resolve of that promise will be content of each file, array, which is the content of each file's content. If any call to read file ends with an error, then promise returned by deferred map is immediately rejected with that error. It's also important. And arrays reduce. And this is basically, there's no more need for processing collection promises. The other one you can use synchronously just on results. So reduce and arrays map are mandatory. Promise extensions. So in deferred, promises are equipped with some useful extensions. Map and reduce, so we can call them on the to be resolved value. So you just call map on a promise, and it will be called when the value is resolved. So for example, we can asynchronously read directory for file names and already schedule to read content of each file. Invoke. Invoke schedules function call on a promise value. So like here, we are producing already resolved promise with an object which has a foo function, and we can invoke that way a foo function on that promise. It also works with asynchronous function. If we expect object that has some asynchronous methods, we can also use invoke for that. Match. Matches resolve list into function argument. It's just handy function, so we don't need to, resolve an array into variables. Pretty plain and easy. So there are a bit more extensions. You can see it in the documentation. And you can even write your own if you're missing something. So we've been introduced to promises. Let's look back at our Node.js example. This is how it was. And we will write it with promises. So we already have promiseified versions of Node.js functions, yes? So we read dir. In return, we have a promise. We are invoke filter using invoke extension. So to take only JavaScript file names and not lib.js. Then we map it. And we use read file, also promiseified read file. So that map resolve only after all read files will be resolved. Then we are just invoke join on the result array. And then we use asynchronous write file. What about error handling? We just stick it to the end. Yeah. What future? Yeah. Few more words about what future standards have to offer. So currently there's no plans for promise implementation in Harmony, but basically I don't miss it. I think it can be written like deferred. It's perfect for me. But what's interesting, you can find promises in Dart. Yeah, API is not as versatile when I look at it. So basically they have like, instead of 2 possible resolutions, they have 3, completed, cancelled, and failed. To me, cancelled and failed are both errors. And I think they can be handled like that. You need to use 3 different methods, so it's maybe not that convenient API. If promise is resolved with another promise, you need to run a flatten to get really final value. It won't be like your result value will be a value. I think it will be a promise. So it's not that great. And there's a bit different approach to grouping. There's just 2 functions, join and wait for. And I'm not especially convinced by those functions. But anyway, I don't write in Dart. I haven't used it. Maybe for Dart programmers, it's very good. I don't know. So see Dart spec for more than that. Well, let's look what real future has to offer. Harmony. There are no promises, but is there anything else that can help us? Coroutines. I won't delve into like this concept in detail, but it can help us with callback style. Yeah. So instead of that, we can write it like that. So we keep our flow in current scope. So it might be very handy for callbacks, but I think not for promises, because I'm not sure how to handle same way error flow as you do with promises. So it won't work well, I think. Yeah, but we have proxies, and this is really magic. Proxies are very powerful. with proxies, we can proxy property names onto resolve promise value. I think this is the most demanded feature from the Harmony that we are waiting for. So instead of using that invoking extension that I presented before, we would be able to write directly what function you want to call, what property you want to get, just in the promise object. So with internal support from promise implementation, that will work. Let's improve our example with proxies. So this is our example without proxies. And as you see, we can change all invoke functions directly with a filter call, like here. Yeah, and join. And I just marked the places which differ from our Asynchronous version. So the first one is because of the Node API nature that it needs to be passed encoding. This is the only reason why I used enclosing function, not read file directly. And the other thing is error handling. We didn't think of error handling when thinking Synchronous. So basically, we got the same plain code, very readable code. Any questions? What? What I was talking about? Can I do it again? Oh, one question. Where's the man with the microphone? Oh, they left me here. Okay, so can you shout? Raz, działa? Raz? Nie? A moment. Where's the switch in here?
It's asynchronous.
So I see. Oh, dzięki. Thank you.
Hello. Okay, it works. So the main thing I'm missing, actually, is you've shown a lot of code and show a lot of examples how to use deferreds and promises. And my big question is this some common approach that these frameworks you've presented in the beginning are sharing, or is this one specific framework which you've shown how to use in different cases? Because this is what I'm not sure about, not clear about at all.
Well, promises is a known concept. I think it dates to 1970 something, not sure. And there are quite a few implementations. So these implementations share basic concept of promises, but API is a bit different. Like, for example, in other implementation, you need to use always promise.then. Here I made so promise is a function. And like promise if a function is like external add-on, so you can work with asynchronous functions. Basically, there are, I don't know, about 5 implementations of promises for Node, but each one is very different. It's same concept, like we have an object, but the API a bit different. That .then thing is the same, like promise.then, and that you have that object that you attach callback. So this is the concept known and already like proved that to be good concept. So it's not the thing that I involve.